Hello, Alexis. How's that going?
Hello, Stefano. How you doing?
I'm doing good. It's such a long time. Like this summer really is flying
Yeah,
away.
it's been busy. It's been busy.
Yeah. Okay, I know you got some really interesting stuff to put on the table today. So, okay, let's remove like this
Yeah,
simple
we were trying to figure out what to
stuff.
talk about. There's my
Oh,
latency work. There's breakthroughs in the Jacobian conjecture where I made a small
yeah.
contribution. There's
That's funny.
there's that. There's also a Pi extension that I wrote that seems to have gotten picked up on Twitter, and now hundreds of people are liking it on GitHub. So I thought we could talk a little bit about that Pi extension and that topic, if that's good with you.
Yeah, I love it. And like it was fun because you did it this past action a little bit ago. I think that
Months
even
ago,
mentioned
yeah,
it
months
already in
ago.
this same podcast before. And you say, oh God, someone discovers it. And you get even like a tech
Well,
team.
it just goes to show I don't know how to use social media because I just put it there and I never even tweeted about it, and someone else tweeted about it, and now like it's got like hundreds of likes and
Okay, someone
retweets.
else tweeted for you at the end
Oh
of the
wow,
day.
it has 1,000 likes now. Okay.
Okay,
Um,
let's share your screen.
okay. So let me share my screen. So all right, here we go. So this, oh wait, no, is that the right one? Yeah, okay, that's the right one. Yeah, so this was the retweet from Kun Chen. I'm not sure if I'm pronouncing his name right. And I think it does a good job of summarizing the issue and then linking to this Pi extension that I created. But let me just, uh, so what he's saying here, pro tip, when you use OpenAI's GPT models in Codex, it uses a server-side encrypted compaction that seems to work better than anything else out there, which allows Codex to just keep hammering on long-running tasks like there's an infinite context window. That's great, but if you run GPT in other harnesses like Pi, most of them don't inherit that by default, resulting in worse performance in long-running tasks. But because of how extensible Pi is, I just found this cool extension from Alexis Gallagher that enables the same server-side compaction in Pi. Benchmarks seem to support the argument that OpenAI server-side compaction is indeed superior. So if you're using GPT models in Pi, install that extension to improve long-running task performance. First rate benefits. First mate benefits a lot from this. I don't know what first mate is. If you are using other harnesses, be aware of this difference and see if you can find a similar solution. So I think Kun puts it very well, but let me just provide a little more color on the background because I think I may have mentioned, I probably mentioned it in this podcast earlier. So everyone
Yes,
who,
yes. We
all of
talked
our
about
dedicated
this
readers,
a bit
they're
ago.
like
Yeah.
ahead of the curve. They don't need to wait for Kun Chen to retweet it and for 1,100 people to like it. They can like find out early. So all 10 of you who are out there,
That's a good one.
you're on the cutting edge of the wave. Yeah. So where is this coming from? So I got very interested in using Claude Code very heavily. I don't know, February last year, and I was vibe coding way before it was cool. And but over time, I started switching to Codex instead of Claude Code um, because at some point it became pretty clearly better. And I don't know why it was better, but just empirically, when I was using them both side by side, it seemed to be better. And one of the differences definitely seemed to be that Codex could just keep going across compaction boundaries without losing its brains. So it used to be, when you see a compaction boundary coming up, I would need to like very carefully instruct the model to prepare everything into a markdown file and like, say goodbye. It's like your kids leaving for college, and then you come back and they're a different person, and you give them the markdown file and you hope, they remember who they used to be. There's a lot of like drama and ceremony.
You're
But I don't do
describing the
any,
way I work at the end of the day. It's very careful. Say what is the
yeah.
percentage? Like pi gives
I
you
don't do any of that
percentage.
anymore. I just fire up
You
Codex and
know.
like run with it. And I have Codex sessions that have been running for days and weeks. And I kind of, instead of worrying that my Codex session is so big it's gotten stale, I now worry that it's so new it doesn't have like the full context. So I just basically act as if I have infinite context. Now sometimes that's not true, and that's a mistake. And it's very subtle, I think, to know when it's a mistake and when it's not. But a lot of times it works just fine. And so why does it work? Fine. I was trying to figure this out. And I think part of it is that Codex is doing the Codex harness, maybe in a way that's been co-designed with the most recent GPT models, the 5.5 and on, are doing something special with compaction. Like the way they compact is different. So to recap, compaction is when the model looks at a lot of material that it's not going to be able to keep all of and squishes it down to a smaller amount of material that it's going to keep. And it does this basically by using a prompt that says, hey, summarize all this into the stuff you need to remember, like what to do next. That's all that's going on under the hood. Um, as far as we know, certainly when people build compaction things that they see in public, when a harness says like compacting. But the recent OpenAI models, um, when you use them in the Codex harness, do something different. Instead of them applying a text prompt and then generating like summarized shortened text that's used to keep track of everything in the past, they go to a endpoint that OpenAI offers, a compaction endpoint, and then OpenAI does something on their servers to compact the old context, something on their servers. And what are they doing to compact their context? Nobody knows. Nobody knows because they haven't told us. And they'll give you back the compacted result so you can hold on to it, but it's an encrypted blob. So, good luck, buddy. Here's your compacted context, but you don't know how they've compacted it because they're just giving you an encrypted pile of bytes so that you could feed the bytes back to their system later. Um, and at first that led me into exciting science fictional speculations that they were doing something incredibly clever under the hood. Like instead of taking text and like compacting it into more text, they would save the wait activations or save some latent space representation, even save logits, save something, not just the final, not just the final text, some more efficient, like deeper representation. And maybe that's how their compaction was working better.
I was thinking
Um,
now at the Razer, Occam's Razor, that they would probably have like a session to memorize everything on their side that maybe running, I don't know, an RLM or something like that that just grabs important thing every
well,
time.
I don't know.
So
I
it's
mean,
like we talk.
there's a
I
number
just
of
think that we talk a lot of times about like context length in this like series of episodes. Like,
well, well, context length is one of the biggest single like engineering constraints on the way these systems work right now. It affects memory, it affects inference quality, it affects cost, it affects inference speed. So there's like nothing that doesn't depend on context length. Um, and it's worth enumerating things they could be doing. So they could be compacting to some secret like latent space representation that's like very cool. They could just be compacting to some text, but they could have a really clever prompt for it. They could be using a dedicated compaction model, which is different than the model that they're using for inference, right? Like a custom tuned compactor model. They could have trained their models to work especially well with the structure that's produced by their dedicated compactor model. There's all kinds of things they could be doing, but we don't know what they're doing. Someone did a little clever reverse engineering and managed to exfiltrate the prompt that
oh,
they actually use to compact things. So we know, they're not like doing something totally incomprehensible, but that only tells you the compaction prompt. It doesn't tell you what the output format is or how it's used or, if there's been like
mm,
co-design in the training of the models to use the compactor.
I didn't know this thing, but if it's like that, it's I feel that is probably the idea you put down that is a dedicated compaction model, maybe smaller, so it's gonna be
Yeah,
cheaper.
but that could
Compacting is
just
one
be
of
an
the most
efficiency
expensive thing
optimization.
you're gonna do when you compare.
Right.
You're
Okay, so
actually
let me get to that
using
because that's
everything.
like that's the news that hasn't made it to Twitter yet. So I had just empirically observed, despite everyone getting excited about Claude Code, I'd already moved on to Codex, and I found Codex is better, and probably it's better because of compaction, but I didn't know why. And that was the reason I stopped using Pi and just started using the Codex harness as well instead. But then I realized because Pi is extensible, I could create an extension that like reproduced exactly what the Codex harness does. And why can I do that? Because the Codex harness is open source. So instead of me looking at the compaction endpoint and like deciding how would I want to use it, what I
Trying to
did is I
reverse
just
engineer the stuff, of course.
yeah, I just got an agent and said, look at exactly what the Codex harness does. It's written in Rust or whatever when it uses the compaction endpoint. And make a Pi harness that does exactly the same thing. I don't want to understand what it does. I don't want to second guess what it does. I just want to mimic what it does in Pi. Um, so it created that extension. And then I wanted to do comparisons. So like I have this, very strong but non-quantitative impression that Codex compaction works better. And then I was just like, okay, well, let's run benchmarks. So I prompted agents to do systematic benchmarks comparing Codex compaction, in this case implemented by the Pi extension. So there could be an error in implementation, but I'm pretty confident of it. Codex compaction with like Pi's compaction. And the benchmarks are very clear. Codex compaction worked a lot better. And that's
I
where it stood.
remember you showed me some numbers, dude.
Yeah, if you look at the results, it's dramatic. Like, if in the first kind of wave of benchmarks, which is the one that was publicized here, let me see if I can find. So here's the repo, compaction benchmarks, and then I have native versus text as the old benchmarks, but here we have the new ones from 20 minutes later. So the kind of report
Crash.
here, yeah. So native compaction, 100% accuracy. Uh, Text summary is like 80%. Uh, some of the tasks, some of the particular categories have dramatic differences. 100% versus like 35% in terms of the accuracy. So, um, these are different benchmark category tasks that the agent came up with. Did I carefully hand design and curate all these to make sure they were like extremely well designed benchmarks? No, I've got other things and I'm not getting paid to do this. So everyone out there who's saying like you can't trust the agents, I agree. Go do it yourself and tell me what you came up with. I would appreciate your free
Yeah,
labor on the topic. Thank you very much.
exactly. You got
Um,
like a more use cases, just put it down. We're gonna add it.
yeah, if you got some great ideas, go do it and tell me because I want
Yeah.
I want to know the
Tell
answer.
me the podcast too. We're gonna love
Yeah,
it to have
yeah.
it
Like
here.
I'm not pretending to know more than I do or to do more than I do. I'm just trying to get on with my life. Um, but I believe this partly because I my um
It was like your guts.
my empirically personally established sense of what I can trust the agents to do, and partly because it comports with my own um, qualitative experience of the difference in compaction. But as I was, but this got picked up on Twitter. People were talking about it, and then I became worried that there was an asymmetry in the way this thing worked because the procedure that it's using here is it asks the native compactor to compact, right? And then it looks at how many tokens it used to compact. And then it goes to the non-native compactor, the text compactor, and says like, all right, this is how many tokens you get. So that's to produce a kind of token matched comparison. Because what
Okay.
was originally motivating me was this more specific question of is Codex doing some clever thing that makes every token, every compaction token like higher information? Like are they using a latent space representation? That's what I was kind of wondering about.
Or just a caveman representation.
Right, right. And the asymmetry here is the native compactor gets to go first. It decides I'm going to use 1,000 tokens or 10,000 tokens. And then the text compactor gets like cut off. If its result took more than 10,000 tokens, well, that's bad luck, right?
Oh, okay.
So in some sense, it's fair because they're both getting the same allocation,
Yeah.
or actually a budget matched allocation. Um, but in some sense, it's not fair because the native compactor got to decide how much compaction, how many tokens it wanted to use for the compaction, and the text compactor didn't. So the original results I reported are still correct, um, but they don't exactly, but they were intended to try to identify is the native compactor doing something special that results in a better result. And it showed that it gets a better result, but it didn't like strongly confirm it was doing something special. So
You
just
was
today,
focusing on like the token efficiency, like the
yeah, token
number.
efficiency, token efficiency. But I think it was a somewhat biased comparison because everything wasn't kind of allowed to do its own um,
Mm.
uh, allowed to do its own settings. Um, so what I just did was I ran another benchmark. These cost like $40, $50 a piece, um, where each compactor is allowed to do what it wants to do. So this is just a comparison of default policy, right?
Okay.
If I use the extension to do a Codex native style compaction with the Codex native style defaults, and then I use Pi to use its defaults. What do you get? Um, Drum roll. So here's the new report, which I pushed up, and I also made it more difficult. Like I made the task more difficult so that the native compactor would fail sometimes because it was like more information than it could fit.
Yeah.
And the result is yes, Codex Compassion works better than native compaction still, so that's not incorrect. My impression was correct. But part of the reason it may be that the main reason it's working better is it just uses more tokens. That like the default pi compaction is too stingy and has a like hard limit on how many tokens it's going to use, where the Codex native compaction policy will, um, if it's a very long context, just decide to compact to a larger number of tokens. So it's like it may be because it's adaptiveness. Um, I'm not sure exactly. And one of the things I was working on here, so here's again. Oh, and consequently, the Codex native compaction costs more because it's like using more tokens. So like there's a like dollar difference. Um, uh, and there's a difference in token use, and consequently also a difference in here you can see like native versus pi.
Yeah,
Like
but
natives,
it's not really Apple versus Apple. It's like
yeah, yeah.
comparing, like you compare the outcome in the
Yeah,
same way,
if your
but
goal is to
the way
have
they're doing is different.
if your goal is to have the most effective harness, which can support super long contexts, and you don't want to like tune things, and you're just wondering which one works better by default, the answer is Codex. The answer is Codex. I'm pretty sure of that. If your goal is, uh, you know, spend the least money and you don't care if your compaction works, then the answer is pi. If your goal is
Yeah,
to
but
exactly
okay,
tune it, if your goal is to exactly tune it and have control of it, then the answer is read this report and exactly configure things the way you want.
and
You know?
install the extension. But
Yeah.
the other question I have is that on the quality of the answers, I understand that the purpose of compaction is like reducing. So the more you compact, the better is the outcome, of course, because you have more like context to use for your next stuff. But in terms of like, okay, the best compaction is like throwing away everything. So I
Yeah,
would
but then you run
expect
into
even
context
some,
limits,
yeah, I would
right?
expect that even some of the measure like how is the system then responding with the compacted stuff? Did you try to make like some follow-up question, understanding like
Yeah, no, I mean you
that
can
is very difficult and like to
yeah, well that goes to the
measure.
thing I was showing earlier, which is that there's different kinds of tasks. A lot of
Yes,
it was just recall tasks. So you're trying to compact, so you have in the context a lot of factual information. Like,
cool.
this is the exact path of this file, and it needs to be
You throw away, so of
remembered
course you're going to
correctly, right?
something.
And then there's other kinds of tasks like here's information to ignore, distractor resolution. Here's task continuation. Can you continue this task successfully, or did you forget so much information you
This is an
can't
interesting
continue?
one. Yeah.
So, like again, like I'm not pretending I looked at all of this like in detail, but I did like prompt and guide it and like shape it along the way. My assumption is the way it kind of the way I kind of YOLO'd it to just prompt this benchmark is reasonable. But again, I welcome anyone who wants to spend more time on it.
Yeah.
But let me get to the issue here. So I think that one of the most valuable things, when you're working with agents to try to get useful results is just to be really clear in your own thinking and what you're asking. So when I was prompting this just now in another window that I could share if you're curious,
Yep.
I'm trying to distinguish the different claims, right? Like what's
Mm,
actually been tested and what hasn't. So if you're interested in this topic and you're trying to figure out like what the benchmarks show, absolutely, what they don't show, what they suggest, what hasn't been tested in any way at all, like that's what this table is for, right? So there's different kinds of questions here, and some of these have been clearly tested, and the documentation's right there. Some of them are very plausible inferences. Some have not been sufficiently not isolated because, like, you know, f
of
use of
course.
full history versus not use of the full history is confounded with other like factors in these tests, so you can't make clear
You
statements.
can't do ice stack in a needle in the ice stack with the
Yeah,
compacted stuff versus like the full context.
yeah. So like the whole like is
By the
native
way,
more
I love
accurate?
because this is really in the direction, the wholeness approach that we try to put down in this like little series of
Yeah.
talks.
Yeah, so I don't know. Like I'm excited that people have taken an interest in this finally. I'm embarrassed that I don't have a like a better presentation of information, but it's nice that what I have is clear. I think this is a reasonable way to operate, to try to just be really specific and drive the agents to do the benchmarking. Hopefully they're not embarrassing me by doing totally incorrect benchmarking, but I think I have a pretty calibrated sense of where they're reliable.
Yeah.
My personal takeaway from this is I'm probably going to stick with Codex because I am confident it's doing the right thing. Um, I may go back to doing some things with Pi, but it requires some attention. Like I need to configure Pi to perform as well. I think my extension's as good a way to do it as any. I actually raised this issue in the Pi Discord, and like no one seemed to care. They were like, "Oh, if you're interested, go do it on your own." So I went and did it on my own. Um, and like,
Okay.
yeah, okay,
Yeah,
Pi's not as
we
good.
should convince like the Pi community
I think
and Mario
Pi,
to like
if I look at
set
how
this
Pi is
option
being
as default
developed,
because it's not even it's the OpenAI option at the end of the day. You just
I'm yeah, I mean, I
in
think
their endpoint.
the way it's great that Pi is so open, it's great that Pi is so extensible. It's not great that it doesn't come out with great defaults from the start. And this is a thing I've said a few times. And like the compaction policy, the compaction policy, if you just walk up and start using the compaction you get is dramatically worse than Codex is a product failure, right? Like in my opinion. Like it's nice that I can
It's
configure
something
it.
to take a look at. It's something to take a look at. But
Well,
according to
yeah,
the
I wouldn't want to
man,
like
you're an Emacs user. Like you're talking about defaults. It's like it's
well
fun.
yeah, but I don't pretend Emacs is good that way. Like the fact that if you download Emacs and run it, you have a piece of garbage is a problem, right? It's great. This is actually the analogy I made that Pi is a lot like Emacs. It's like super configurable, and that's awesome, but it doesn't start out particularly useful because the defaults aren't good, and that's not awesome. I mean, I don't know if Mario is listening. If I am, you are. I apologize, Mario. I love your work. We should hang out
Okay,
sometime.
you want to
But
have like a Mario on the podcast? It will be incredible. But
yeah, no, I'd love to. Yeah,
but okay,
I'm
I think you make a really interesting point here. And again, maybe I use more Cloud Code than Codex in that
Codex
way,
is better.
and
Codex is better.
really more Pi between the two. Yeah, again, I still feel that I want to have an understanding of my context, and if it's gonna grow too much, it means that I have a design issue, or I have an task issue, or an understanding issue. So like, I
Maybe
still
you just
stick.
have a harness issue. Maybe you're just not configuring your harness right, and you don't need to worry about context growth.
It's correct and then not correct, as you say at the beginning. So my answer to that thing is that okay, I will try to not have a big context, but I totally understand it. I will never have noticed the thing
My
that
code base
I
is
noticed
so
because
big
I
I can't
try to
avoid
keep my
having a big
context as small as
context.
possible.
My
And
code base is approaching 100,000 lines of code. There's no way to avoid large context.
it's refactoring the code bases. And I like example in Pi, I use a lot the tree command that like I do my exploration, that I save my stuff, as you said before, agent or whatever MD file, and then I come back to the tree knowing that I know how it's growing my context. But of course, it's work, it's more pressure on my like understanding than really focusing on the problem. I totally agree with you. Just say like it's so fun that we have kind of like a really different approaches in the, like doing
Yeah.
this stuff.
Well,
So we have
I'll tell you what I
different
do for
strategies.
context management. It all starts with tmux. If you go look at my tmux, I have like 10 sessions or 8 sessions that are running. Every session is kind of segregated around a topic. So I have a
Yeah.
session now called compaction, which is just for work on compaction. I have a section called dev, which is general robot dev. I have a section, uh, I have other what do they have?
Yeah. I personally send you
Yeah.
my personal script that serialize all the state of all Tmax because that is the thing.
Yeah, so I have a session here for
Yeah.
Jacob for Jacobian, a session here for Jupe, where I'm building my own private Jupyter extension. I have a session for Macafy for improving support for deployment on the Mac. And then
And
within each
each one of
session,
those session is an independent
yeah,
context
and then
for a
well, no,
specific
because each
task.
session has like 5 windows, and then the windows might have they'll have
Of
different
course.
chat sessions, have different codec sessions,
Files
and some
for
of those are topical. So like recently, I was doing work, very kind of deep work on the latency, and I ran into a point where there were two things I wanted to keep doing afterwards. One
yeah.
thing is I wanted to create a suite of benchmarks that tested latency of various toy examples, informed
Yeah.
by the work I'd done on the robot. And then the other was I wanted to create a suite of latency benchmarks that tested latency on the robot. And I wanted each of those pieces of work to be informed by a lot of fairly deep stuff interrogating the like sources of latency. So there I used the fork command to create two chat sessions that both had the
Yeah.
same prefix history, and I put those in different tmux windows, and that way I could both of those could
That's the
benefit from the
tree.
history, but
I do this all the time. This is tree
yeah,
stuff.
so yeah, so like I am doing some context management, but it's not I'm not doing intense context management to keep context short. It's more about um not
Mm.
wanting to like add stuff that's going to be totally irrelevant, like if I go down one latency discussion route. Anyway, so
Yeah,
that's
that
the
was super
exciting.
interesting. Like, okay, we got a 25 minutes now, so yeah.
Yeah, we're way past.
We'll never be able to make the 50 minutes share. So it's no, wait, really, it was super interesting, and it is the link of all the new PDF with all the documentation stuff on
Yeah,
the
yeah, it's all pushed to
yeah.
GitHub
So
for
we
anyone
will
who's curious.
attach it, yeah, at the bottom of the video, all this stuff. So okay,
Yeah. All
cool.
right, man. Good to see you.
Yeah, me too. Bye.
Okay.
See you.
Bye-bye.